What the? Tadaomi? Where is...
Anji's son couldn't come today, so he asked me to come in his place. Anyway, it appears you brought Hina-chan here too.
You know, Neja, this place is really bopping.
Well, I guess.
Hey, can I go to the left side of the screen?
Anyway, since Angela's not here, can you give us the next problem?
It's a rather simple one, I've heard.
The product and chain rule. For those who don't know, the chain rule is a way of finding the derivative of a function composition, f of g of x. While the product rule is used to find the derivative of the, well, product of two functions.
It's one of those basic things you learn when learning calculus. And we have to find a proof of those two?
That is correct.
Anyways, let's get started.
Oh, Sayo.
Tsugumi? Tadaomi, I'd like you to meet Tsugumi Hazawa. Tsugumi, this is Tadaomi Kurama.
Nice to meet you.
Nice to meet you too.
So, what is it we're doing here?
We're doing calculus.
Maths. I'm not really good at it.
Don't worry, Tsugumi. We'll make sure you understand what we're doing.
Oh, I want to show my proof for the product using the modifiable chain rule. But I guess if it's what Tsugumi say.
To start off, this is the definition of the derivative again.
Wait, that is a derivative? What do these triangles mean? What does this part mean?
Oh, I think we need to explain what a derivative is first. That's not helping.
Don't worry, we can make it easy for Tsugumi to understand. Say you're filling up a cup of coffee, and you want to find out how fast you're filling it at a given moment.
Why would I want to do that? I guess I can measure how much time it takes for me to fill it up, and then divide the total volume of the cup by that.
That may work if you're filling up the coffee cup by a constant rate, but as an expert coffee maker, you surely notice that you sometimes speed up and slow down.
Then
Say you want to find out the rate at which you're filling it 2 seconds after you've started filling up the cup. What you can do is find the volume of the cup at that point, and then measure the volume again ever so slightly later.
You can code a duration between these 2 points in time, delta P.
And we can call the volume of the cup t seconds after the beginning, v of t.
So your second measurement will be equal to v of t plus delta t.
I understand. I think. So, I'm guessing we can divide the difference in volume by delta t, I guess. Am I getting this right?
Spot on!
Now that's all well and good for an interval, but for a single point in time, if you calculate it the usual way, you'll just get 0 over 0, and we don't want that. However, what we can do is let delta t get smaller and smaller, and never letting it actually hit 0.
That's what this part means. It says, as delta t gets closer to 0, this expression approaches some number. That number is the derivative of the volume function, written dv over dt. Now we can finally get onto the product rule. Say that, Hina, help me.
Say you want to figure out the price of the cup of coffee. However, the cost per volume is changing as you fill up the cup.
Why would it be changing that fast? And who charges coffee by the milliliter?
Don't worry about it.
So now you want to figure out the price at point T. Call it P of T. And it's equal to the volume times the cost per volume. Call it C of T.
Here's the derivative of p, and we can replace p of t with v of t times c of t. Now, what if we add and subtract v of t times c of t plus delta t?
Notice we have a c of t plus delta t here and here, and a v of t here and here, so we can group them together. Now, did you notice anything?
Not really.
Well, what if we split up the fraction and treat them as 2 separate limits summed together? Now do you notice anything?
Hey, this part is the same, just with c of t plus delta t.
So we can treat them as a product of two limits. Same goes with the other one. We can replace these with derivatives and notice that as delta t goes to 0, c of t plus delta t just equals c of t.
And that's how you get the product rule. I really hope that was easy to follow.
Finally, the chain rule. First, I want to ask you a question. How are you supposed to find the volume? I mean, it's not like you can dump it out while you're filling it. What if you measure the height of the coffee at each moment in time and calculate the volume from there?
Let's call the volume of the coffee in the cup when the surface of the coffee is h centimeters high, V of h, and the height of the coffee after t seconds, h of t. Then the volume of the coffee at time t is V of h of t. Let's put that into the definition of the derivative.
That's called the difference between the height of the coffee at times P plus delta T and P delta H. Now, you agree with me that as the time interval gets shorter, the difference of height at the times also gets smaller.
I can see that.
Bring back the definition of the derivative of v with respect to t. We can add and subtract h of t here and then replace this part with delta h. Now here's the fun part. We multiply the numerator and denominator by delta h. Replacing delta h with its definition here, you can see that we can split the fraction and then treat it as a product of two limits. Now as you noticed before, as delta t goes closer to 0, delta h goes closer to 0, so we can change this to this. But this is just the derivative of v with respect to h. And this is the derivative of h with respect to t, so we could replace them and voila! The chain rule.
Did you understand all that?
Not really, but why can't you just multiply the numerator and denominator by dh?
It's not a fraction. Well, it kind of is. Maybe. We had a whole video about this. Go watch it.
Anyways, stay tuned for SoME4 Episode A.